In this presentation, we'll be discussing bending conduit using hand benders. So hand bending is very common when it's smaller pipe or tubing. However, when you go over an inch and a quarter, usually we start using hydraulic benders. But the principle of bending will be the same. So section 1 and unit 7, module 7, we will be basically selecting and using hand bending equipment. And so the objectives of this section is to select and use hand bending equipment. We will use geometry to understand how the bends are made. We will be practicing how to make 90-degree bends and to make offset bends. There will be a performance task, which we'll do in a classroom in the lab. And what we will be doing is making those bends, a 90-degree bend and also a 90-degree back-to-back bends, making offsets, saddle bends using a hand bender. The equipment itself is very simple. There's a handle, which is basically a pipe, and the bending shoe. Hand benders are available in various sizes and used to bend rigid conduit and also electrical metallic tubing, which we call EMT. EMT, or sometimes you call it thin wall, are talking about the same thing, up to 1.25 inches in diameter. Now, when you get to 1.25 inches, that is probably the largest pipe you're going to try to bend by hand because it is very difficult, the larger pipe. 1/2 inch, 3/4 inch pipe, maybe even 1 inch is probably the farther most guys would go. The same bender can be used on different sizes of EMT and rigid pipe because their inside diameter varies. In other words, the outside stays basically the same, the outside diameter of it, but what happens is that because of the rigid, the wall thicknesses are thicker, so the inside diameter is actually less. So again, look at this picture, and I'm going to try to point out a few things using my laser. Uh, Usually the electrician will be facing the tubing bender, where they're going to be trying to bend towards yourself, not away from yourself, but towards yourself. So they would reach over with the handle. Actually, this handle here will be located in this area on the straight pipe. And when they bend it, pulling it toward them and pushing it downward, it will be lifting this stub piece. In other words, stubbing up. And of course, this handle is a certain distance to give you leverage. And again, this is the bending shoe. And another thing too, his foot will always be pressed down on this portion of it to give it stability and also to help to bend it. So if you notice, his foot is on the pipe to keep it from moving, and his other foot is on the bender as he press down and pull toward themselves. So again, using two hands to help stabilize it, because you don't want till they actually start bending the tubing, you want to make sure that it doesn't slip or move to throw off the bends. So again, your foot, both hands are used. Another type of bender called hockeys it is used for rigid metal conduit. It bends it easier, but it does it in incremental steps. So it will make a lot of small bends to make the bend you're looking for. So again, the thin wall is very simple. You can bend it all in one bend up to 90 degrees. Anything smaller than 90 degrees, you can definitely use it. But when using a hockey, those are typically used for rigid pipe because the wall thickness are thicker and it's harder to bend. Also, another type of bending that you would find more on the commercial side is PVC, polyvinyl chloride piping. Uh, that you cannot bend with a bender on a normal condition. However, you have to heat the pipe up to soften it up, and then you can bend it. But you would hold it in place to allow it to cool down. And so, in other words, once you heat it up, you can bend it, and then you can use like wet rags or something to help cool it off to speed up the process. Again, a little heater unit is used to soften up the PVC piping. Now, another thing too, because the PVC piping, it is soft, it can flatten out, it can be deformed. So they would use another component, a tool, to help keep it in place, which we call plugs. Plug sets are used for PVC that is 2 inches in diameter or larger, and because, like I say, that it can lose its shape and deform it. So plugs help prevent the PVC from flattening during the bending, and is removed after it cools down, so it stays in place. But again, the large pipe would take a while to cool off, so again, you can use wet rags to help speed up the process. Now, making any bends, um, we will use math, using geometry to figure out the bends. So let's look at this triangle. This is a right triangle because it's 90 degrees. And so it has a height, has a base, and the diagonal line is what we call the hypotenuse. And many times we know what the base length is, we know what the height is, but we do not know what the hypotenuse is. But we can use math to figure it out. Basically, Pythagorean theorem would be used to determine the bends. So again, if we're using conduit, let me see if I can move my picture. But let me close this out real quick, if I can. Well, to make bends, we're bending here a certain degree, and then bending as if it's leaving straight out, we would make another bend. And again, all triangles will equal 180 degrees. The right triangle will always be 90 degrees, and then the other two angles must equal 90 degrees together. So if this is 90, this is 45, and this is 45, it will add them together, will equal, again, 180 degrees. So again, we're looking at that, and when we're making bends, so your tubing bender, your conduit bender, will have degrees markings on it to help you understand where to bend and how to bend, how far to bend, because it should not ever be guesswork. It should be precise bending. So going over some really basics about within a circle, there's 360 degrees. Okay, if you start at the very top of the circle, starting at 0 degrees, you go at a right angle, it would be 90 degrees. Continue around, another 90 would be 180, and continue 270, and back to the top where we started at 0, now would be 360 degrees. So a circle will always have 360 degrees. We just divide it up. So when we're making 90-degree bends, basically we just, again, it's just a quarter of a circle, just like you see here. This, from this point to this point, is 90 degrees. Let me go back to that slide again. Well, I guess I'll come back to it. To make a bend, and it's making 90 degrees, you must know the stub up. The stub up is the distance where you need to, for example, if you have the conduit on the floor, laying flat on the floor, and you want the end, you want to bend it 90 degrees, and you want it to stop, let's say at 12 degrees. That 12 degrees, or I'm sorry, 12 inches, you're going to make a 90-degree bend, and you're going to, you want it to bring it up 12 inches. So you make the 90, the distance from the floor to the end of that pipe is your stub up. Again, that would be your 12 inches. 12 inches. So again, to make a bend, you must know the stub up length and the take up distance of the bender. All benders have a certain take up because of the radius of that 90-degree circle, that quarter of a circle. That distance of the radius, or let's say if the radius is 4 inches, it has a certain amount of distance that it must take up. In other words, it's the portion of the circumference of a circle. So a 90-degree bend is basically a quarter of a circle. So the distance of that circumference, the circumference is completely outside, the distance of the outside of the circle. So we take a quarter of that circle. I'll show you on another slide when we get to it so you can see what I'm explaining. So the take up is the amount of the conduit that will be used for to form the bend. So in other words, it's the distance of the pipe that you're bending in that radius, or in that the distance of that circumference. Again, circumference is the distance that the outside of the circle would take up. So again, the bend, and it is listed on the manufacturer's instructions for the bender. So every manufacturer have instructions to go with their bender. It's pretty uniform with in the industry what the take up is, but I always say verify it just in case you got a bender that came from China or some other place. It might be slightly different. And yes, all benders are slightly different from each other's. Once you get a bender, learn your own bender, because it may be a quarter inch off or an eighth of an inch off or whatever. But once you learn it, you will know how to make your bends. Thirdly, to make a 90-degree stub up, you will subtract the bender's take up. So in other words, that quarter of that circumference, you actually will subtract it from that distance, because when you bend it, we'll actually add it back to it. So to make a 90-degree stub up, subtract the bender take up from the stub up height. Mark that distance on the conduit. So once you subtract it, that is where you're going to start your bend. That's where you will start it. So once you subtract that amount from your stub up, that measurement that you subtracted from that total. So whatever is the balance, whatever the answer is, that is where you mark it on your conduit, and that's where you start your bend, because you will be adding that radius back to it once you bend it. So mark the distance on the conduit and line it up with the starting point on the bender. All benders will have a starting point. They will have an arrow pointing to it, or have some other. Matter of fact, there's a lot of different markings on your bender. You may find a star. Of course, you have degrees and on your bender. So hold the conduit with one foot and press the foot pedal with the other. Keep the bender perpendicular and bend towards yourself in one single motion. Pull it towards yourself in one single motion. So after making a bend, check for accuracy. In other words, using some type of square. In other words, I like, if I'm working in a building that got walls and they got floor tiles, and you can see a line, if you know that everything's squared up, I just lean it against the wall and see if it lined up. Or you, like I say, you can use a square to do the same thing. There's many different ways you can find something that is straight to make sure that it is square. Let me go back again. So in other words, the bend, if you're trying to go 18 and you subtract your your take up. Let's say your take up is um, let's say 5 inches. You would subtract 5 from 18. That would leave you 13. So I would mark it at 13. That would be my starting point. So when I bend it, so remember that the conduit is actually laying flat on the floor. You mark it at 13, then you put it on. So oh, here we go, right there. So 5-inch take up. So this must be half-inch conduit. A 5-inch take up is a normal take up for half-inch conduit. So let's take a look at that again. So you want it to be 18, but I will subtract that 5 from that to make it 13, and that's where I would start it, right there. So when I bend it, the radius will be added to it to bring it back up to exactly that 18 inches. So again, so the take up, to make a 90-degree stub up, subtract the bender, take up from the stub up height, mark the distance on the conduit, and line it up with a starting point. Hold the conduit 1 foot, press down the foot pedal, and of course this is the foot pedal right there, with the other foot, and keep the bender perpendicular and bend in one single smooth motion, and then after making the bend, check for accuracy using a level or a square. Again, here's what we call gain, determining the gain. The gain is the distance saved by an arc. Arc is the circle, the circumference. For example, let's take a look. If you had a square and measure from here to there, let's say it was 18. However, the pipe would be a little bit less than 18 because it's not taking it all the way to the end. We're saving some. So the part we're saving is called the gain. The gain. So the gain, again, is the distance saved by an arc of a 90-degree bend, because it will not go all the way to the end, even though it's making that bend. So you're saving some material. It is important to know the gain before cutting or threading conduit. Rigid pipe is threaded. The developed length of a 90-degree bend can be found by adding the length of both sides and subtracting the gain. Let me say that again. The developed length of a 90-degree bend can be found by adding the lengths of both ends and subtracting the gain. So in other words, if I had this against a wall or a floor or something and measure out to the end, that'll give me a distance. And then if I stood this up on the floor again and went to the top and measured it, that's the distance. If I add these two together and I could subtract my gain, then I know what the length of the pipe will be, which is extremely important. That would save you a lot of lost pipe or cutting off extra pieces of pipe and just wasting time. So if you know what the gain is and you use that number, you know exactly how long the pipe would be. So in other words, you can bend the pipe ahead of time, cut the pipe, and then bend it, and it will be exactly the size you want it to be. So a lot of guys just bend it, then they just cut. Then they bend and they cut. What I'm saying is that these numbers are standard, and you will be able to use them to be able to help determine lengths of pipe to keep from wasting time cutting off little pieces. What call uh-ohs. Oh, I made it too long. I made it too short. But been able to know exactly what they should be. Now, here's making a back-to-back 90-degree bends. To make a back-to-back bends, you will make the first bend as usual, just like you normally would do. You would just take the measurement that you need, and then you will just bend it. Then you would need to measure the required distance between the bends. So in other words, if you're going, if this pipe, like you see here, is going to be installed, and yes, you can bend this in one bend. without adding any couplings or anything if it's less than 10 feet in total length. So um, you can do it exactly the way you need to by, again, measure the required distance between the bends from the back of the first bend, mark it on the conduit. So in other words, once you know that distance, and let's look at it real quick. I have the length here from end to end to fit into that box exactly. So I need to measure from the end of this box in the opening to the end of that box at the opening. So now I know how long it needs to be. So once I bend this, all I need to do then is add it to the end of the pipe to that. That would be my mark. And so um, you place the bender in the back-to-back indicator marked at this point and bend up. So now you will actually bend it and it will fit. Of course, you're going to need to cut the extra pieces of pipe off, or unless you know the total length, you can cut it ahead of time if you know the game. Offset bends, and usually offsets are made if you need to change the direction of a pipe. If there's something there, you need to take it to a different plane. So let's say going from a lower ceiling to a higher ceiling, it's going to make an offset. So an offset consists of two equal bends. Here's the reason why. When you make two equal bends, it will always come up to be on the same plane. In other words, 180 degrees. So again, you're making two of the same bends. So an offset consists of two equal bends of less than 90 degrees each, and is used to route conduit over objects, or it needs to bring something up to a different plane. So to avoid a difficult wire pull, here's the reason why. You get too many 90s in it, it'd make it very, very difficult to pull wire through the conduit. So making 45s has a lot less resistance than making two 90s. I can do the same bend with making two 90s. However, it's going to be a lot more difficult to pull the wire through. So using a smaller angle than 90 degrees will work. So again, the distance between the bends is equal to the depth of the offset times a multiplier. So there will be a chart we will use to figure out these bends using a multiplier. So let's look at this real again. So we're going to make a bend here, and we're also going to flip the pipe around and make a bend here. These two angles, here and there, are going to be exactly the same. This bend and this bend going to be exactly the same bend. However, we need to know this distance. How high do we need to go? And so in other words, you can know exactly where to make the second bend based on taking a measurement of the height, the offset depth, and using a multiplier. Offset angle multipliers represent the cosine of the related offset angle. In other words, the offset in the rounded part of it. So basically, we're using geometry and trigonometry, but it's not that difficult because this all on a chart that we use. It's all figured out. So you just be using a multiplier to help. So the shrinkage, it will shrink. In other words, when you're bending back, you're actually eating up some of the pipe. In other words, that you're pulling it back. So the shrinkage must be multiplied by the height of the rise. In other words, how high you're bending it up, and subtracted from the developed length. So again, shrinkage must be multiplied by the height of the rise and subtracted from the developed length. We're going to look at this in a second so you can see it. But that is basically making an offset. Matter of fact, offsets are a very common bend that we use on a regular basis. use offsets for connecting boxes together, offsets going around obstructions and things. Making a parallel offset. The conduit length must be adjusted when making parallel offsets. In other words, we have multiple pipes running parallel next to each other, and because of that, so everything lines up correctly. In other words, let's say there's a 3-inch gap between this pipe and there's a 3-inch gap between that pipe. Let's say we're going center to center, we've got 3 inches. But to make it look right and consistent, the distance between each one of these will be exactly the same way. And because, let's look at this first pipe. It starts to bend there. But the second one, we start the bend a little bit farther down, so the distance where you start to bend is actually increased. And that third one is increased more, but it will follow a pattern. So in other words, they all the same height here. They will end all at the same height at the bottom. But so the distance and to make it parallel, we would use a table and charts to be able to determine what that should be. The amount to be added is equal to the center to center spacing. So in other words, like I said, if I wanted them spaced center to center 3 inches apart, that would be what I'm using. So the amount to be added to equal to the center to center spacing times the tangent of one half of the offset angle. So the tangent value can be found again in Appendix A. But like I say, there will be charts that you can use to help determine that. Makes your job a lot easier. Making parallel offsets. This is how we would do it. To create a parallel offset, first find the center of the first bend of the innermost conduit, the innermost. So again, we're looking at this one, and we see it's 3 inches. Okay, and say find the center of that, and we can see that we're looking at a distance of 12 inches. This outermost, innermost, but we're looking at again the um, the distance between it. Okay, we're using math again, and here's something how much we're going to bend it, 15 degrees. But the starting point of the second the second conduit is found using the offset formula. We bent the first one. So first, like I say, 12 inches, where we're going to start it, center to center spacing, times the tangent of half of the offset angle. Half of the offset angle. So if it was 30 degrees, what was the angle that we used for the offset? We were going to take half of it, so going to be 15. We find the tangent. So in other words, on the chart, for looking at the tangent, it's on a chart, it would just say that, tangent or tan. You will look at that, and it will give you a number at 15. And that's the number you would use. So it would be 12 plus 3 times the tangent, which is 3 times 0.2679. And that would equal 0.8, which is about a little bit less than 7/8 of an inch. So 12 plus 0.8037. Like I say, it's just slightly less than 7/8 of an inch will be where you start your next. So this, it is then added to the starting point measurement of the first pipe. This value is added again to find the starting point of the outermost pipe. So again, we are using these different numbers so everything can line up correctly. So let's take a look at it. The first one is 12. The next one is 12 13/16. And again, that's 1/16 less than 7/8. That's why I just rounded off real quick to 7/8 of an inch. The next one, you add it again. So basically, we adding the distance to each one of those to equal what the offsets, the distance, so you know where to start it at. Saddle bends. Saddle bends, if you just need to continue on the same plane, let's say you mounting um, conduit on a ceiling, and but a plumber ran a pipe right where you're going across. Of course, you can't go through the pipe, and you need to continue on. So we can make a saddle. A saddle is basically just going around it and dropping back down to the same plane again. So saddle bends are used to route conduit around obstructions again, just like offset is. Offset is different, it's taken to a different plane where saddles are going to the same plane, the same level. So making a saddle bend will cause the conduit to shorten because every time you bend it, you shrink in the pipe because of the radius of each one of those bends. So shortened by a specific amount for every inch of saddle depth. So in other words, based on that angle you're bending it at, depend on the size of the conduit. So they have charts for that also. So you will know what that take up or that shrinkage is. So once you start to bend it to go around that obstruction. So here's a couple of things you need to keep in mind as we go through this. We're making a saddle. First, you need to know exactly where the center of that obstruction is at. And then you need to know how high you need to go above that obstruction. So once you get that information, now you can use the charts to know where to start to bend and where to finish the bends. Again, that would be planned ahead of time once you take those measurements. In other words, if you measure from a wall to the center of this pipe here, so you can get that measurement. Now you need to know how high you need to go around that pipe. And so that information, you can use the charts to help you determine how to bend it. Again, they show you here, the center was 15 and 3/8. I'm sorry, yeah, 15 and 3/8, where you started. This adding the shrinkage to it, because when you bend this, it will shrink it back. So basically, the center is 15 inches, add your shrink to it, and so when you bend it, it will come dead center to that. So again, if you had a pipe, you're bending it, it actually got shorter because of the bends and the height that you're going around it. So we call it shrink. The pipe is not shrinking in actuality, but it's just getting shorter because of the bends. So making saddle bends. First, the value from the shrinkage chart is added to the measurement from the end of the conduit to the center line. This ensures that the bend will be centered over the obstruction. In other words, it's not, it doesn't look weird. It is balanced. So if you look at anything from an electrician or any pipe fitter or any craftsman, things being level, centered, plumbed is extremely important. That's how they can tell the difference between a amateur or a journeyman, or a homeowner, or a DIYer compared to an expert. So again, we learned the right way. So we do it correctly all the time. So making a saddle bend, again, like I say, it's a 3-point bend. And the interesting thing is where you start first, second, and third with these bends. And you actually will be flipping the pipe around. And I'll show you in the next slide how we would do it. But the order of bending is extremely important. Once we find where we start the bend, then we measure back from the charts we get. So here it says using the value for a 2-inch obstruction found in the shrinkage charts, each bend is located at 5 inches from the center line. Like I said, the charts will tell you that based on the size of the pipe and based on how high the obstruction is. And this happened to come out to 5 inches. but the order of the piping is important too. So again, the first bend, we're bending it toward us. The second bend is in the opposite direction. And actually, if you notice, it's upside down. So we actually, the first bend, we actually bending it on the floor. The second bend at B, we actually put our handle on the floor, turn the pipe upside down, and we will just hold the pipe in our hands and using the handles on the floor, maybe sometimes using your feet to actually stabilize it, to keep it from moving around. But we will actually press down. And here's the great thing. If based on the bends or the degrees of the bends, it would tell you how far away that you need to go. So again, you can do it, like I say, 45s, you can do 30s, it doesn't matter, but there's a chart to help you bend around it. So this saddle contains one 45 and two 22.5. And if you add those together, that equals 90 degrees. 90 degrees. So again, a saddle. And here's one great thing about saddles. It has less resistance going through it, so it doesn't help with the, there are some obstructions, but it's not as bad as having multiple 90s. Multiple 90s. So 145 and two 22.5s. And one more thing, so the third bend, it is actually done upside down too, and you actually be pushing down on the bender till you get to the 22.5 degree marking on your bender. So the handle's on the floor, you're stabilizing it with your foot, and you're just pressing down on it, the third bend. So you pull it out of the this here, flip your conduit around, and it is on the floor, and you actually putting pressure on the conduit to bend it. Making a 4 bend saddle. Again, if a very large, a 3-point saddle, going to be not going to work out very well. Uh, it looks better because of the distance and the angle. That's the reason why. Actually, if a 3-point under a very high obstruction, you have to maybe go up to keep from hitting it or touching it. You may have to bend the pipe up very high, that center bend. So with a 4-point, you can keep it just above the obstructions. Basically, it's almost like doing an offset, 2 offsets back to back. So a 4 bend saddle must be laid out carefully in order to avoid wasting conduit. Because if you don't bend it correctly, it might be extending out too far. You may end up throwing it away, or you're just leaving it and it just looks unprofessional. Again, taking good measurements is extremely important. So a 4 bend saddle is created using 2 offset bends, like I said earlier. Just 2 offset bends. Again, we finding it out where the obstruction is at, how high you need to go, and bending it, and then flipping the pipe around and doing the opposite thing again. So again, let's look at it. To lay out a 4 bend saddle, determine the height of the offset and the correct spacing. Then bend the first offset. Mark the starting point for the second offset and bend the offset. Remember to use the multiplier for the offset angle, and account for the shrinkage. So again, just make sure that when you're thinking about the shrinkage, it is added to it. So again, you know where you're going to start. You know where your second bend is going to be, and then you need to measure how wide is the obstruction, so you know where to start your second bend. So use an offset bender for wall-mounted boxes with exposed conduit. Um, it is automatically matches the offset to the box knockout position and is a great time saver when making multiple offsets. So now what they're saying here, when you need to go into like uh, outlet or some type of wall-mounted box, and you got the conduit um, basically strapped to the wall, but where the conduit goes into the box, it's not against the wall. So you have to offset it, the conduit, to go directly into it to make it sure it is center instead of going off at an angle or looking sloppy. So offsets, these type of offsets is extremely important. So again, um, we can, uh, like I say, the first bend could be done on the floor. After that, you're doing it above the ground. So let's talk about some of these terms again, just to go over as you review. 90-degree bend basically is a bend that changes the direction of the conduit by 90 degrees. Back-to-back bends are any bend formed by two 90-degree bends with a straight section of conduit between the bends. So concentric bends. Concentric bends are made of two or more parallel runs of conduit with the radius of each bend increasing from the inside of the run toward the outside. Developed length is the actual length of the conduit that will be bent. The gain is because the conduit bends in the radius and it's not at an exact sharp right angle. Is a radius, or we could call it arc. The length of the conduit need to be that for the bend will not equal the total determined length. So the gain is the distance saved by the arc of a 90-degree bend. The offset. Offset is the is two bends that is placed in a piece of conduit to change the elevation. In other words, need to center it into a box when the pipe was attached to a wall, but the box with the knockout in that box is not flat against the wall. It is offset from the wall. So your conduit need to be offset to go into it. So again, but offsets can also be used to go around obstructions. So offsets is, like I said again, is a very common. So the rise is the length of the uh, bent section of a conduit measured from the bottom center line or top of the straight section to the end of the conduit bend. So in other words, the distance is traveling upward. We can call that the stub up also. So the rise is the length of the bent section of the conduit measured from the bottom or the center line or top of the straight section to the end of the conduit bent. The segment bend is a large bend formed by multiple short bends or shots. And that's where, like I say, the hockey benders are used for like for rigid pipe, making a lot of small bends to make the angle that they're trying to find. Stub ups, another name for the rise in the section of the conduit at 90 degrees. Also a term used for conduit penetrating a slab or the ground. In other words, if you got the conduit buried in concrete and is coming out of the concrete, so it could go into the wall, we call that the stub up. or the rise. Question. I could stop right here. You guys should answer it. But let me just do this first one, and then we can end it. The first bend made with a hockey should be about, just think about it, because it's this very short bends, small increments. For example, if it's a rigid pipe, you cannot bend it without damaging the pipe, so they make a lot of small ones. They're close together. So it would be 10 degrees. 10 degrees would be the correct answer. 10 degrees. Let's go ahead and finish this. Go through this to help get us caught up. A 90-degree bend is also known as again, a 90-degree bend is also known as a stub. Stubbing it up. When when making a saddle bend, remember a saddle could be a 3-point or it could be a 4-point. But when making a saddle bend around a 4-inch obstruction will cause the center of the saddle to be shortened by, of course, you need to look at the chart. So if you look at the chart, um, for saddles, is in your book, it would be 3/4 inch.